Hi everyone, welcome to Demystifying Research YouTube channel. Today we will be interviewing Dr. Eric Bombardier. He is currently an instructional assistant at McMaster University. So in this interview series, we will be asking Dr. Bombardier a few questions about his research interests and LifeSci 2803.
To start off with our interview, could you please introduce yourself and your research interests and what have you been currently working on or have worked on previously? Specifically, would you be able to discuss your research in this article, specifically the one on sarcolipin and how it provides a novel muscle-based mechanism for adaptive thermogenesis?
Okay, sure, no problem. My current research interests revolve around calcium handling, a protein called SERCA, which is a sarcoendoplasmic reticulum calcium ATPase. It basically pumps calcium back into the sarcolemma, thereby causing relaxation. Other things I'm interested in are sarcopenia, cachexia, muscle regeneration. So, and for my previous background, what I've studied in is a whole mess of things. I did my master's looking at migrating salmon, enzyme activities in migrating salmon. I don't know if you're aware of this, but once salmon enter a river, they stop eating. So therefore they become, their muscles go through large amounts of changes. I've also looked at the role of estrogen in muscle repair, heat shock protein, gender differences, calcium handling proteins. Like I mentioned, SERCA is what I did my PhD thesis on, which is the role of sarcolipin in calcium handling and obesity. This paper, Sarcolipin Provides a novel muscle-based mechanism for adaptive thermogenesis. This came about in 2006 is when I started my thesis work, which was the role of sarcolipin in calcium handling and obesity. And what we did here is we fed genetically modified mice that had sarcolipin knocked out of them. We fed them a high-fat diet, and we compared them to mice that had sarcolipin. And what we found was that, well, when you lack sarcolipin, these mice tended to get more obese and become diabetic much more quickly than your regular mice or your mice that weren't genetically altered.
So our next question for you is, what was the most difficult challenge that you faced while pursuing research in your field? And in particular, what made it so challenging and how did you overcome it?
There's two different answers here. The first one was financially. I wasn't your average PhD student. I didn't start my PhD till I was in my mid-30s. I had a young family. As you know, grad school doesn't always pay the best. So personally, what I did is, well, I got NSERC funding, I TA'd, as well as I taught courses at Wilfrid Laurier at the same time to try to basically. And the other thing with doing a PhD, especially when you have a family and little kids, is that you really got to make time for both. And that was pretty challenging for me. Like I said, I also was teaching and TAing as well, all at the same time. My second answer to this, if we look at, let's say, my research project or my research thesis, was that, as I mentioned, sarcolipin is only 31 amino acids. It's a tiny protein and incredibly hard to detect. It basically shows up at 6 kilodaltons on a Western blot. You guys know what that is, Western blot looking for protein. So one of the major difficulties was, well, there's two major difficulties. A, there was no commercially available antibody. So we had to get the antibody made by another company. Once we got that made, we then had to figure out how we would be able to actually measure it using the Western technique. Like I said, normal proteins, we run them through an acrylamide gel. An acrylamide gel that's about 6, 7, 8% maybe. However, since this protein was so small, we had to use a 15% acrylamide gel. So basically, which means it's a lot thicker, so the protein doesn't go through as quickly and doesn't get shot out from the Western. The other thing is, this didn't work with normal acrylamide, so we had to go to what is called the tricene gel, which this sounds like it wouldn't take very long, but this took literally probably 6 months to a year to be able to finally detect this little tiny protein. So those are two big things I had to deal with.
just our next question. How was your experience in navigating through these factors that differentiate mice models and humans, especially when you're like making those connections in your research and your study?
Okay, yeah, there are huge implications here. One of the biggest ones, I don't know if you guys have ever heard the term thermal neutrality. This is the optimum temperature a species wants to be at to be metabolically most efficient. And for mice, this is about 30 degrees Celsius. So all of my research was done at room temperature, which is usually about, I think we kept it at 20 to 21 degrees was where they at. And when they're, just a couple examples, when they're at 21 degrees, mice heart rates are at about 500 to 600 beats a minute. When they're at 30 degrees, the heart rate's at about 250 to 300 beats a minute. So it's a massive difference. So this is where I think the field is going, and they're going to have to look at, not just for this particular study on this particular protein, but for all studies that use mice as a model organism, because that's a major factor. If it would be like us having our heart rate at, I don't know, 130 all the time.
Perfect. So our last question is, how would you go about conducting future studies, keeping in mind the limitations of this previous study?
Thermal neutrality, I think, is the way future studies should go, especially when looking at the mouse model. Just because, like I said, the physiological and biological systems are pretty much really ramped up at 21 degrees. Right? It'd be like sticking us at, I don't know, putting us naked outside at 12, 13 degrees, right? So our systems would be going a little bit haywire. Same with the mice. Well, I think that's a really big step. Another really neat step, I think, would be, instead of knocking out sarcolipin, would be to overexpress sarcolipin in a different genetic model. So I think those are the two ways this research is going to go. And hopefully from there, research can find a way to either detach sarcolipin from SERCA so it doesn't have an effect. There could potentially be a drug out there that will detach it from SERCA. But like I said, that's for future studies.
Okay, thank you so much for that. So as you know, LifeSci 2A03 is a course that introduces students to the application of the scientific method in the life sciences by exploring different research studies and their limitations. What advice would you have for students that are interested in enrolling in LifeSci 2A03?
4 words: be curious and question everything. If you have taken 2A03, one of my favorite tutorials is the one on research ethics, because it shows you that science isn't perfect, right? And just because it's written in a paper, be skeptical. Doesn't mean it's true, because people make mistakes.
Yeah, that was awesome. So that sort of wraps up our interview. Thank you so much for taking the time to come out and interview with us. And please check out our YouTube channel, Demystifying Research by McMaster University. Thank you.
No problem. Thank you for having me.
Thank you so much.
Well, thank you.